The ratio of 5 to 7. Sometimes we write it this way. The ratio is always a fraction. The first number is your top number. The second number is always your bottom number. Instead of 5 to 7, it might be written like this. The ratio of 5, instead of the word 2, we use colon, 7. That's the same thing. That's 5 to 7. Now we know we have 14 ladies in the class here. 14. And we have 2 men. I'll count myself with you. I'll keep you company there, Rob. There's 2 of us here. If I go, what is the ratio of women to men? The ratio has to be a fraction. That's 14 over 2. When you simplify it, you have to write that 7 over 1. That means for every 1 man in this room, we have 7 ladies. That's the ratio. For every 1 man, there's 7 ladies. Now, if I do, what's the ratio of women to the total number? 14 over 16, which is what? 7 over 8. So when you try to simplify, it's called simplifying ratios. Now you can't have decimal in ratios. You got to have a number on the bottom. Even if it's 1, you still have to leave it 7 over 1 if it's a ratio. If that was just a plain fraction, you'll never write 7 over 1. That would be wrong. Because 7 over 1 as a fraction is 7, but as a ratio, you have to write it 7 to 1, 7 over 1.
There has to be 2 numbers?
Yep. Now, sometimes you have decimal values. We might give you the ratio of 1.2 to 2.5. So when you make that a fraction, that's what? 1.2, 2.5. Now, you can't be decimals here on the bottom. They can be fractions. They have to be whole numbers ratios. So how do we change that to 1.2 and 2.5? What do we do to make them whole numbers? Move the decimal 1 place for each one, and that becomes what? 12 to 25. Can we simplify that?
No.
No.
So what happens if the decimals are in different places?
Okay. The question, what will happen if the decimals are in different places? The ratio of, let's talk about mileage in your car. I'm doing a ratio. You drove, what, 170 miles? And you used, not 4. 4 would be a nice car. Good. You used 7.4 gallon of gasoline. What is the ratio in miles per gallon, basically? That's what that is. So the ratio will be what? 170, 7.4. Now the question was, what would you do if the decimal values are in different place? Now notice this doesn't even have a decimal value. So the decimal is right here.
But whatever you do to the top, you have to do to the bottom, right?
So if I need to make this number a whole number, that's a whole number, but this is not.
Right.
So if I move this 1 place, I'll move that 1 place.
And we just add the 0?
Yep, so that'll be what? 170 to 74.
No, wouldn't it be
1,700.
Yeah.
Yep, 1,700 to 74. Now you can simplify that, because notice the last digit is what? Even. You can divide them by 2. By 2, this is what? 37? And by 2, 8 times 2 is 16, that'll be 10, 850. So the ratio is 850 to 37. Let's take you back to chapter 2. I keep going back to that. The ratio of 2 1/3 to 5 1/2. I'm going to keep bringing these till you get these fractions done, mastered.
7 over.
That will be what? 2 1/3 to 5 1/2. And how do you simplify? You can't leave it as a fraction. You can't leave it as a decimal. It has to be a whole number.
2 times 3.
3 times 2 and 1. 2 times 5. 10 and 1. That's still not good. Because you want the numbers to be whole numbers. These are a fraction, not whole numbers. Well, if you look at that, what does it say to us?
Make them decimal.
Oh no, decimals you go back, because they'll be rounding. It says 7/3 divided by, that's what it says to me, 11 over 2.
So then you do the reciprocal.
Yep, that's 7/3 times 2 over 11. And how do you multiply that? 7 times 2. 3 times 11. So the ratio becomes 14 to 33.
See how much more we could get done if we just take our exams at home?
Well, it's true. Well, you know what that means. I got to make sure you're doing the work. Let's do a ratio. You can use that. Where can I use ratios? You might be wondering. Lots of places. An example. You might say, you know what? I worked this week. I worked 40 hours. And I get paid. My pay was $600.
You better be making more than 600 for 40 hours.
Well, because you were on the phone a lot, so they didn't pay you much, Maria. What is the ratio of pay to hours? So the pay is what?
600.
600 to 40. Can we simplify that? Notice these will cancel each other out, because that's dividing by 10. And you end up with what? 60 over 4. Can you simplify that? 15 to 1. What does that mean to you when you look at 15 to 1?
For everyone.
Yep, everyone what? Hour that you worked,
Hours, 15
you
hours.
get $15. That's your salary, $15 an hour. For every hour that you work, they're going to give you $15. The word, a lot of times you'll see the word per. Per in math means divide.
Yeah, those terms came in handy for me, Z.
The homework? Yep. Per means divide. So if we said, what is your rate? $1 per hour. If you see that, that tells you what?
Yeah.
The dollar has to be on the top, which is the 600, and that per means divide. The hours has to be on the bottom, which is what?
40.
40, and that's why the ratio is 15 to 1. For every hour that you work, you're getting paid 15 bucks. That's your rate. You can use it if you are driving. I was talking to this gentleman who just came from Vermont over the weekend to visit, and I go, must have been a nice ride with the foliage. He goes, I didn't see any of it. What do you mean you didn't see it? He goes, I spent my whole time turning backward, yelling at my kids in the back seat. He has 2 little kids in the back seat. So you can use that in terms of miles per hour. If you drove from Vermont to Springfield, and let's say you drove 200 miles in 4 hours. Here's the question. What is your miles per hour? Your miles per hour. Miles is written first. I got to put the miles first. 200. Per means divide. Hours is what? 4. Simplify that. That's what? 50 over 1, which is 50 miles per hour. Every hour you drove 50 miles.
Professor,
Yes.
you can do a ratio with Y and Z letters too, or no?
You can do a ratio of anything. What's the ratio? If I say y to z, you can write y over z. Yep. So the first one that you see, so for example, just take this. If I write, but usual ratio has numbers in it. But let's say we have the number of cats. You have a farm, and you have, I don't know why you have so many cats on the farm, but I wrote cats. So you have how many cats? 20 cats. And you have dogs here, 30 dogs. If I say, what's the ratio of cats to dogs? That says 20 over what? 30, which is what? 2 to 3. For every 3 dogs, you have how many cats? 2. So if you want to use letter, what is the ratio of C to D? C on the top, D on the bottom. So if I say, what is the ratio of cows to donkeys? D, the other direction. See, I'm getting now messed up. Yep. Cows to donkeys. And then you think about it, I went through Ludlow, and there's a guy who has cows and donkeys. They were on the farm. I saw fellow donkeys.
And
Yeah.
then I work out there.
You do?
Yeah.
Yep. They have buffaloes too, I think.
They have a lot of animals out there. I stopped
Buffalo,
by
yeah.
to look at the cows.
Cows to donkeys, so that'll be cows on the top, donkeys on the bottom. So the ratio could be anything. Now, where ratios come in handy in something called unit pricing. What does that mean, unit pricing? Let's take an example. So we use ratios for unit pricing. I go to Big Y. We'll use Big Y here. And I want to buy a coffee. Usually I don't like to buy coffee from Big Y, but let's use that example. And you get the big jar, which has, or big can here, which has 30 ounces in it. So this jar says 30 ounces in it, this can, and the price on that, here's the price. If you want to buy it, it's $7.80. Or you can buy the little can, which has 12 ounces on it, and the price $3. 3. Which one is a better buy?
The big one.
Because it's bigger. We assumed because it's bigger, the price is cheaper. It might be.
Well, no, because if you do 12 plus 12, that's 24, and then that'll be $6, and that'll only give you 24 ounces, and 30 ounces is more than 24. And then for $1.80 more, you're getting 6 more ounces.
Let's see if she's right.
All right, maybe I'm not. Never mind.
I think she's wrong. It's called unit pricing. Let's get the price per ounce. Price per ounce. That's where ratios come in handy. Per 1 ounce. Let's take the big jar. Price per ounce. Price, which is what? $7.80 over 30. By the way, if you want to use pennies, because this is in dollars, right? If you want to use pennies, that's what? 780 cents per 30. Maybe you can get the price per ounce in cents. You know, per cent. So let's find what the price per ounce. Well, here's the good news. I can cancel these zeros, right? It's 78 divided by 3. There's my decimal point. Keep in mind, when you're dividing decimal, there's infinite supplies of zeros, right? If I need them. So here's my decimal point. 7 by 3 is what? 2. 2 times 3, which is 6. 18 by 3, which is what? 18 by 3. 6. 6 times 3, 18. Done. So the ratio is 26 to 1. For every ounce of coffee, the big can, you're going to spend 26 cents. Let's look at the little can now.
Why'd you add all the zeros?
In case I need them, because I don't know if it's going to be a whole number or not. I wasn't sure. So if that was decimal value, then I have to bring in the zeros. Now let's look at the little can here. Price per ounce. The price is what? $3 for 12. Let's change it to pennies. That's 300 over 12. Let's see if 300 goes into 12. 2 times 12, which is what? 24. 60 by 12. 5 times 12. 60. So what's the difference? This is 25 cents per ounce versus what? 26 cents per ounce. Now, if you're only buying one time in a blue moon, who cares? You can have your 10 cents. But if you have a coffee shop that you have to go through 10, 20 cans a day, that will add up that difference. That might be $4 or $5 a day, 365 days a week. You're talking about a few $1,000 a year. I'm sure you're not going to throw $3,000 if it's the same coffee and you're going to use it. So that's called unit pricing. You find the price per ounce, and that will tell you which one is a better buy. Most people think the bigger package is always cheaper.
I always buy the
You know?
bigger package.
Yep, and I can tell you, and this I'm not making that up. I went to Big Y one time, and I noticed the bigger one is like almost $1 more than these two little ones. So I called the guy who works there. I said, "Excuse me, I think there's a mix-up here." He goes, "What?" I said, I can buy 2 of these, have the same amount, I'm gonna pay $1 more. Something is not right here.
Right.
No, I said, that's the price. I said, I think you're wrong. Get the manager. So you get the manager. I'm arguing. I don't even need either one. Just got my attention. Now she goes, no, that's the price. And I walked away. I wasn't buying the
That's
stuff.
crazy.
But people think because you're buying the bigger one, it's always going to be cheaper. So that's section 5.1.